Science councils study human curiosity because it drives all progress. Part 1. The chamber existed in 17 dimensions at once, a crystalline structure that bent reality itself into new shapes. Inside, beings from across the multiverse gathered for their monthly meeting. They called themselves the Council of Scientific Advancement, and they had been studying how civilizations discover new knowledge for over 1,000,000 years. Floated to the center of the chamber, his form shifted between states of matter as he moved, a common trait among his species. He carried a data crystal that glowed with a soft purple light. The other council members turned their attention toward him, curious about what he had found. "I have discovered an anomaly," announced. His voice resonated through dimensions that humans couldn't perceive. "A species that pursues knowledge in a way we have never documented before." The council leader, an ancient being named Eth, gestured for him to continue. Eth had existed for 12,000 years and had seen countless civilizations rise and fall. Very little surprised him anymore. Activated the data crystal. Images appeared in the air, showing a small blue planet in an unremarkable corner of a fairly standard universe. "This is Earth. The dominant species calls themselves humans, and they are strange." "Strange how?" asked a researcher who specialized in biological species. Her 6 eyes blinked in sequence as she examined the images. "They pursue knowledge for no practical reason," explained. "Watch this." The crystal showed a human woman working in a laboratory. The text beneath identified her as Curie. She handled glowing rocks with her bare hands, day after day, carefully recording observations. The image fast-forwarded through years of her life. "She knew these rocks were making her sick," said. "Her fingers were burned, her health declined, but she continued her research because she wanted to understand what made the rocks glow. She eventually died from the exposure." The council members murmured among themselves. Hen, a strategic analyst, spoke up. Perhaps her civilization forced her to continue. Was this mandatory research for her survival? "No," replied. "She volunteered. She was obsessed with understanding radioactivity. That's what she called it. She wanted to know how it worked, even though it had no immediate practical application and was actively killing her." Silence filled the chamber. This made no sense according to any model they had developed. Showed more examples. A human named Tesla who bankrupted himself trying to give free energy to the world. A man named Galileo who was threatened with execution, but refused to stop looking at the stars through his telescope. Thousands of humans who spent their own money to send machines to distant planets, not to colonize them or extract resources, but simply to see what was there. "They have a word for this behavior," continued. "They call it curiosity. It means wanting to know something just for the sake of knowing it." "That sounds like a mental disorder," said Hen flatly. "Most species in the multiverse pursue knowledge for specific reasons. The research what their government tells them to research. The X purchase technologies from other species. The simply observe the universe's natural changes. But these humans deliberately create problems just so they can solve them." Nodded. "Exactly. I have documented cases of human children taking apart mechanical devices just to see how they work, with no intention of improving them. I have found records of humans mixing random chemicals together to observe the results. They poke dangerous animals with sticks. They climb mountains that serve no strategic purpose. They dive into oceans to explore places that have no resources. And they do all of this while saying things like, 'I wonder what would happen if.'" Leaned forward, her interest clearly growing. "What are their scientific advancement rates compared to similar species?" The data crystal displayed a comparison chart. The council members fell silent again, but this time it was a different kind of silence. This was the silence of beings confronting something that contradicted everything they thought they knew. "That cannot be correct," Eth said quietly. "Check your data again." "I have checked it 17 times," replied. Humans have gone from primitive tool use to splitting the atom in approximately 10,000 years. That took 45,000 years to achieve the same progress. That took 60,000 years, and both of those species had more efficient research structures than humans possess. "How is this possible?" whispered. Change the display to show a human university. Students sat in classrooms, attended lectures, and worked in laboratories. Human civilization is chaotic, he explained. They have no central research authority. Their scientists often disagree with each other publicly. They waste enormous amounts of time pursuing theories that turn out to be completely wrong. By every metric we use to measure research efficiency, they should be one of the slowest advancing species in the multiverse. "But they're not," Hen said, staring at the data. "No," agreed. "They're one of the fastest, and I believe it's because of their curiosity. They don't just research what they're told to research. They don't just solve problems they're assigned. They investigate everything. A human scientist studying plants might suddenly become interested in insects and discover something revolutionary about biology. A human engineer might spend her weekend building a robot for fun and accidentally invent a new type of motor. They pursue knowledge in every direction at once, and somehow it works." The council debated for hours. Some members insisted this was impossible, that the data must be flawed. Others argued that curiosity was clearly a wasteful trait that only appeared efficient by coincidence. A few suggested that humans might be dangerous, that a species driven by uncontrolled desire for knowledge could destabilize the multiverse. Finally, Eth raised his hand for silence. "We are scientists," he said. "We do not reject data because it challenges our understanding. We investigate it. You will lead a research team. Embed yourselves in human society. Observe this curiosity firsthand. Document how it functions. Determine whether it truly accelerates scientific progress or whether some other factor is responsible for their advancement rate." "Bode, I will need 2 additional researchers." "Take whoever you need," Eth replied. "But be careful. If humans are as curious as you claim, they may notice you observing them and become curious about you in return." Volunteered immediately, her 6 eyes bright with interest. Hen hesitated, then agreed as well, though he made it clear he expected to prove that human advancement was a statistical anomaly rather than the result of curiosity. The 3 researchers spent the next month preparing. They studied human language, human customs, and human appearance. They created identities that would allow them to integrate into Earth's scientific community. They prepared equipment that would let them record observations without being detected. On the day they departed for Earth, Eth gave them final instructions. "Remember," he said, "you are there to observe, not to interfere. Do not share our technology with them. Do not influence their research. Simply watch and record. We need to understand how curiosity functions in its natural state." Now wearing the form of a middle-aged human man nodded. "We will be careful." "I doubt that will be enough," Eth said quietly. "If these humans are truly as curious as your data suggests, being careful may not be an option. Curiosity has a way of spreading to those who observe it." The 3 researchers departed, traveling through dimensions until they arrived on Earth. They had studied humans for months from a distance. They had analyzed thousands of hours of recordings. They had read human books and watched human entertainment and memorized human scientific papers. But nothing could have prepared them for what they were about to experience. Because understanding curiosity from a distance was one thing. Being surrounded by curious minds, seeing it in action every single day, watching humans pursue knowledge with joy and passion and reckless abandon, that was something else entirely. Would later realize that the moment they arrived on Earth, the Council's experiment had already changed. They had come to study curiosity, but curiosity, they would learn, was not something you could study from the outside. It was something that pulled you in, made you part of it, infected you with its own relentless drive to understand. The real experiment had just begun. Part 2. human form sat in a small office at Cambridge University. He had taken a position as a visiting physics professor, a role that gave him access to researchers and students while explaining why he asked so many questions. His office window looked out over a courtyard where students hurried between classes, their arms full of books and their faces bright with purpose. A knock on his door interrupted his thoughts. A young woman entered, barely 25 years old, with dark circles under her eyes and a coffee stain on her shirt. Her name was Dr. Sarah, a postdoctoral researcher studying quantum mechanics. "Professor," she said, pronouncing his name carefully. He had told humans it was Persian. "Do you have a moment? I want to show you something." Gestured for her to sit. This was exactly the kind of interaction he needed. "Of course. What are you working on?" Sarah pulled out a laptop and opened a document filled with equations. "Okay, so you know how I've been trying to prove that quantum entanglement can be maintained over cosmic distances. I've run this experiment 47 times now, and it keeps failing." "Perhaps you should try a different approach," suggested. This was how they would handle it. When an experiment failed repeatedly, you abandoned it and tried something more promising. Sarah looked at him like he had suggested she abandon a child. "What? No, the experiment is failing because there's something I'm missing, something in the math or the setup or the theory itself. Every failure teaches me something. Look, on attempt 33, I got this weird spike in the data right here." She pointed at a graph. "It shouldn't be there according to standard theory, which means either my equipment is broken or the theory is incomplete." "And if your equipment is broken," asked, "then I fix it and run the experiment again," Sarah said, as if this was obvious. "But if the theory is incomplete, then I might be seeing something new, something no one has ever observed before. Doesn't that excite you?" Studied her face. She had been working 18-hour days for months. She was exhausted. Her career advancement depended on publishing successful research, not documenting failures. By any logical measure, she should abandon this line of inquiry. But her eyes were bright. She was excited. She wasn't working these long hours because anyone forced her to. She was working them because she wanted to know the answer. "Yes," said slowly and realized he meant it. "Yes, it does excite me." Sarah grinned. "Right, that's why I love physics. Every question leads to 3 more questions. It never ends." She closed her laptop and stood up. "Anyway, I'm running attempt 48 tonight. Wish me luck." After she left, sat in silence for several minutes. He had just witnessed something that shouldn't be possible according to council theories. Sarah was pursuing knowledge that had no immediate practical application, that might never have practical application, that was actively harming her career prospects, and she was happy doing it. He needed to see more. Across the Atlantic Ocean was having her own revelations. She had joined a team of marine biologists studying deep-sea ecosystems. Her human form was that of a graduate student, which gave her access to the research without requiring her to have an extensive fake history in marine biology. The team leader, Doctor, was planning an expedition to an unexplored ocean trench, had reviewed the proposal and found it baffling. The trench contained no known resources. It had no strategic value. The expedition was expensive and dangerous. "Why are we going there?" she asked one day as they prepared equipment. Looked up from the underwater camera he was calibrating. "Because no one's ever looked there before." Waited for him to continue. He didn't. "That's the only reason," she pressed. "Isn't that enough?" replied. He smiled, clearly not understanding her confusion. "Think about it. Right now in that trench there are probably creatures that have never been seen by human eyes. They've evolved in complete darkness, under crushing pressure, in one of the most extreme environments on Earth. They might have bioluminescence we've never documented. They might have hunting strategies we've never observed. They might have adapted in ways that could teach us entirely new things about biology. And we get to be the first ones to see them. That's incredible." "But what will you do with this information?" asked. Shrugged, I don't know yet. Maybe it'll be useful someday. Maybe it won't, but we'll know something we didn't know before. We'll have added a small piece to humanity's understanding of life on Earth. That matters. The expedition launched 3 weeks later, descended into the trench inside a small submarine, squeezed in with and 2 other researchers. The pressure outside could crush them instantly if anything went wrong. They had limited oxygen. The temperature was barely above freezing. And everyone in the submarine was grinning. As they descended into darkness, narrated everything he saw through the window. Strange fish with teeth like needles. Jellyfish that glowed in colors didn't have names for. Creatures that looked like nightmares but moved with impossible grace. "Oh my God," whispered. "Look at that. I've never seen anything like it." A creature swam past the submarine, long and serpentine, covered in patterns that pulsed with light. Grabbed a camera and started taking pictures, talking rapidly into a recorder, his voice shaking with excitement. In that moment, understood something profound. Wasn't doing this for money. He wasn't doing it for fame. He had actually spent his own savings to charter this submarine because the university couldn't afford it. He was risking his life for pure curiosity, for the joy of seeing something no one had ever seen before. And watching his face light up as new creatures appeared in the submarine's lights, felt something she had never experienced in her 300 years of existence. She felt curious. She wanted to know what that creature was. She wanted to understand how it survived down here. She wanted to ask questions. The feeling was intoxicating. Meanwhile, Hen was embedded with a group of amateur astronomers in Arizona. He had chosen this assignment specifically because he expected it to disprove his thesis. If curiosity truly drove human progress, it should be evident in their professional scientists. Amateur hobbyists shouldn't contribute anything meaningful. He was wrong. The amateur astronomers met 3 times a week in a member's backyard, where they had set up several telescopes. Some of the telescopes were expensive professional equipment. Others were cobbled together from spare parts and tutorials found on the internet. But every clear night, these humans gathered to stare at the sky. A woman named had been mapping asteroids for 30 years. She had a full-time job as an accountant. She had children but several nights each week, she stayed up until 3 in the morning, carefully recording the positions of asteroids, updating her database, calculating orbital trajectories. "What do you gain from this?" Hen asked her one night. Looked up from her telescope, her face barely visible in the red light they used to preserve night vision. "Gain. I know where 30,000 asteroids are. I can predict their movements. I've discovered 17 that professional astronomers hadn't yet. I helped refine the orbit calculations for an asteroid that had a small chance of hitting Earth. How is that not gaining something?" "But you're not paid," Hen pointed out. "You could spend these hours sleeping or relaxing." "This is how I relax," said. "Do you know what it feels like to be the first person to see something? Even if it's just a tiny rock floating in space. I look at that asteroid and I think, I'm the only person in the entire world who knows exactly where you are right now. That's mine. That's my contribution to human knowledge." She went back to her telescope, adjusting it slightly, making notes in a worn notebook. Hen watched her work and felt his certainty crumbling. This woman wasn't an anomaly. All of the amateur astronomers here were the same. They had jobs and families and responsibilities, but they spent their precious free time studying the universe because they wanted to. The 3 council researchers met for dinner at a small restaurant in London after 3 months of observation. They sat in a corner booth, speaking in carefully quiet voices. "I can't explain it," said. "The behaviors I'm observing shouldn't result in efficient research, but they do. My subjects work themselves to exhaustion," added. "They pursue dead ends. They waste time on failed experiments, yet their advancement rate is extraordinary." Hen said nothing for a long moment. Then quietly he admitted, "I think we've been measuring progress wrong. We've been treating scientific advancement like a race toward specific goals, but humans don't work that way. They explore in every direction at once. Most of it leads nowhere, but the parts that do lead somewhere make up for all the wasted effort. It's more than that, said. I've been analyzing the data from Earth's scientific history. Most of their major breakthroughs came from people who were curious about something completely unrelated to their field. A man studying mold accidentally discovered antibiotics. A woman researching radio waves laid the groundwork for technology. They make connections that no systematic research program would find because they're not constrained by predetermined research goals. Shook her head in wonder. The council isn't going to believe this. We need more proof. We need to show them something concrete. Then we design an experiment, Hen said, his strategic mind engaging with the problem. We find a challenge facing humanity and compare their approach to how another species would handle it. We document everything. We gather undeniable evidence. The three researchers looked at each other. They had come to Earth expecting to quickly prove or disprove a simple hypothesis. Instead, they were beginning to suspect that curiosity might be the most powerful force in the multiverse. And the terrifying part was this: they were starting to feel it themselves. Part 3. The Council's emergency meeting was held 6 months after the researchers had embedded themselves on Earth. Stood in the center of the crystalline chamber once more, but this time he wasn't alone. And Hen flanked him, and all three of them carried data that would challenge 1,000,000 years of established scientific understanding. We need proof that curiosity accelerates progress beyond standard research methods, Eth had said when he approved the experiment. Find us something concrete. So they had activated the display. We identified two identical problems facing both humanity and the represent the most efficient research civilization in the multiverse, so they make the perfect comparison. The first problem appeared in the air, a complex theoretical physics question about maintaining quantum entanglement over cosmic distances. The second problem was equally challenging, developing a new material that could withstand extreme temperatures while remaining flexible. Both civilizations began working on these problems at the same time, explained. We did not interfere or provide any guidance, we simply observed. Hen pulled up the approach. They assigned their best researchers to both problems. They provided unlimited funding. They established committees to coordinate efforts and eliminate redundant work. They set a 10-year timeline with clear milestones. Everything was organized, efficient, and systematic. The display showed scientists working in perfect coordination. Their laboratories were pristine. Their data was meticulously organized. Their progress reports were submitted on schedule. After 5 years, Hen continued, they are exactly 50% complete on both problems. They will solve them in exactly 10 years, precisely as planned. Very efficient, Eth observed, and the humans took over. The humans are chaos. The display shifted to show Earth. Dozens of different research groups were attacking both problems from wildly different angles. Universities competed with private companies. Individual researchers published contradictory theories. Internet forums filled with amateur scientists proposed solutions that professional researchers dismissed. Arguments broke out in academic journals. Some groups ran out of funding. Others started from scratch multiple times. This is exactly what we predicted, one council member said. Inefficient and wasteful. Wait said. The timeline advanced to year 3. A graduate student at MIT named James Park was working on something completely unrelated to either problem. He was studying how certain chemicals behaved at the quantum level because, as he wrote in his notes, the colors are really cool and I want to know why. His research led him to discover a previously unknown quantum phenomenon. He published a paper about it titled, "Neat Stuff I Found While Playing Around in the Lab." 2 months later, Dr. Sarah, the same exhausted postdoc who had been failing at her quantum entanglement experiments, was eating lunch when she read Park's paper. She nearly choked on her sandwich. The phenomenon Park had discovered explained the anomalies in her data. It didn't just explain them. It revealed that quantum entanglement could be maintained over cosmic distances using a method no one had predicted. Sarah's 47 failed experiments hadn't been failures at all. They had been gathering data about a phenomenon that no one knew to look for. Within 6 months, the quantum entanglement problem was solved. Not in 10 years, not even in 5 years. In 3.5 years, and only because a graduate student got curious about pretty colors while a postdoc refused to give up on failed experiments. The council chamber fell silent. "And the material science problem?" Ed asked quietly. Smiled, "That's even better." The display showed a 72-year-old man named Robert Martinez working in his garage in New Mexico. He had been an aerospace engineer before retiring. Now he spent his days tinkering with different metal alloys because, as he told his wife, "I just want to see what happens when I mix stuff." Robert wasn't trying to solve the material science problem. He didn't even know it existed. He was just curious about metallurgy and had a workshop full of equipment he'd collected over his career. One afternoon, he combined several elements in proportions that made no sense according to existing theory. The result was a material that could withstand extreme heat while remaining flexible. It was exactly what the aerospace industry needed. Robert posted his results on a forum for hobbyist metallurgists. "Made this weird alloy today," he wrote. "Not sure what to do with it, but it's pretty strong and bendy even when I heat it up. Recipe attached if anyone wants to try it." A materials scientist saw the post. Within 3 months, the material was being tested for spacecraft applications. The problem that they had planned to spend 10 years solving had been solved by accident by a retired engineer in his garage. Total time, 4 years and 2 months. The council members stared at the data. Some of them began speaking at once, their voices overlapping in multiple dimensions. Ed raised a hand for silence. "Explain this," he said "The approach is mathematically optimal. How did the chaotic human approach produce faster results?" Had been preparing for this question for months, because curiosity doesn't just solve the problems you're trying to solve. It solves problems you didn't know existed. James Park wasn't trying to help Sarah. He was just curious about colors. Robert Martinez wasn't trying to help aerospace companies. He was just playing around in his garage. But because humans pursue knowledge in every direction at once, they make connections that no systematic approach would find. They solved the problems they were assigned, added. Humans solved those problems plus dozens of others they discovered along the way. James Park's quantum phenomenon has already led to 3 more breakthrough discoveries. Robert Martinez's alloy has applications in 6 different industries. Curiosity doesn't just find answers, it finds better questions. Hen, who had been the most skeptical at the start, spoke up. "I've analyzed the data from every angle. I've looked for alternative explanations. I've tried to prove this is a statistical anomaly, but the evidence is overwhelming. Curiosity-driven research produces more breakthroughs, produces them faster, and produces more unexpected benefits than any systematic research method we've documented in 1,000,000 years of observation." The chamber erupted in debate. Some council members refused to accept the findings. Others argued that the data must be flawed. A few suggested that the experiment had somehow contaminated the results. But Ed studied the display silently, his ancient mind processing what he was seeing. Finally, he spoke, and his voice carried enough authority to silence the chamber. "For 1,000,000 years," he said slowly, "we have believed that scientific progress requires systematic investigation, efficient resource allocation, and clear research objectives. We have structured our civilizations around these principles. We have taught them to emerging species. We have measured advancement by how closely a civilization adheres to these methods." He paused, and when he continued, There was something like wonder in his voice. "We have been wrong." The chamber fell completely silent. "Curiosity is not a disorder," Eth continued. "It is not inefficient. It is not wasteful. It is the most powerful force for scientific advancement we have ever encountered, and we have been systematically eliminating it from our civilizations because we thought we knew better." He turned to the three researchers. "Prepare a full report. Send it to every council member, every research institution, every educational facility, and every civilization we have contact with. This changes everything." Over the next year, the revelation spread across dimensional boundaries. Civilizations began restructuring their educational systems. The who had always simply observed the universe's natural changes started encouraging their young to ask why. They introduced free research periods, where scientists could pursue whatever interested them. The X, who had always purchased technology from other species, began investigating things themselves. It was uncomfortable. It was inefficient. It felt wrong to races that had spent perfecting systematic approaches to knowledge. But it worked. Returned to Earth one final time before writing his report. He wanted to see Sarah, to tell her that her refusal to give up on failed experiments had changed the course of scientific philosophy. He found her in the same laboratory, looking just as exhausted, working just as late. But she was working on something completely different now. "Doctor," he said, entering the lab, "congratulations on your breakthrough. Your work on quantum entanglement is revolutionary." Sarah looked up and grinned. "Thanks, that was fun, but check out what I'm doing now." She pulled him over to a computer screen covered in equations. "So after I solved the entanglement problem, I started wondering if the same quantum principles might apply to consciousness. It's probably a dead end, but wouldn't it be amazing if it wasn't?" Stared at her. "You've just made one of the most important discoveries in your field. You could spend years refining it, publishing papers, building your career around it." "Yeah, but I already know how that works now," Sarah said. "This consciousness thing, I have no idea if it'll work. I'll probably fail 100 times before I figure it out. But that's the exciting part. That's why I love this job. There's always something new to be curious about." She turned back to her equations, already lost in thought, already chasing the next question. Walked out of the laboratory and stood in the courtyard under Earth's sky. Students hurried past him, heading to classes, arguing about theories, excited about what they were learning. Somewhere on this planet, someone was mixing chemicals just to see what would happen. Someone else was taking apart a machine just to understand how it worked. A child was asking why, for the 1,000th time, refusing to accept simple answers. And in garages and laboratories and universities and backyards around the world, humans were pursuing knowledge not because they had to, not because they were paid to, but because they were curious, because they wanted to know, because they found the universe fascinating and couldn't help but investigate it. Thought about his own civilization, about the X, and all the other species in the multiverse who had forgotten how to wonder. They had become efficient. They had become systematic. They had optimized their research until every unnecessary element was eliminated. And in doing so, they had eliminated the most necessary element of all. He looked up at the stars, and for the first time in his 300 years of existence, he felt truly curious. Not about a specific research question, not about a particular problem, just curious about what was out there, about what he might discover, about what questions he might ask that no one had thought to ask before. Humanity's gift to the multiverse wasn't any single discovery. It wasn't a technology or a theory or a solution to a problem. It was teaching the universe how to wonder. And once you learned how to wonder, once you felt that pull to know more, to understand more, to explore more, you could never go back. You could never be satisfied with assigned research goals and predetermined outcomes. You would always want to know what was around the next corner, what would happen if you tried something new, what mysteries were waiting to be solved. smiled. It was a human expression, one he had learned during his time on Earth. Then he turned and walked back into the university, his mind already racing with questions he wanted to explore, problems he wanted to investigate, ideas he wanted to test. The council had sent him to study curiosity. Instead, curiosity had studied him, and he had never been happier to fail at his assigned mission.